Okay, lesson 6. So recall the following formulas from earlier lessons. We have the fundamental counting principle. We have factorial notation. We have permutations where order matters. We have permutations with repetitions, which means we have to divide out the repetitions. And we have combinations where order does not matter, which is n choose r. So in problem solving, it is essential to determine whether order is important or not. And that's usually the hardest thing people have with this portion of the unit, is to say, does order matter, doesn't order matter? So basically you need to decide is if we choose two things, A and then B, is that different than if we choose B and then A? And in some cases order matters, and in some cases it doesn't. So example 1, how many arrangements of the word poppies can be made under each of the following conditions? Without restriction. So that means we are taking these 7 letters and arranging them. So we could do this by either the fundamental counting principle or factorial notation. But we need to make sure we divide out our repetition. So in this case we have 3 p's. So that means we need to take our 7 factorial and divide by 3 factorial, which gives us 840. So that one's really simplest to do as a permutation with repetitions. B, if each arrangement begins with P. So now we need to begin with P, so we can take 1 P out here. And we have 6 letters left to arrange, but 2 of those are still P's. So we're going to divide that by 2 factorial. And there's only 1 P, so sorry, I should have really written a 1 here. This is 1 times 6 factorial over 2 factorial, which is 360 ways this can happen. See, if the first 2 letters are P's, so now I have 1 times 1. Those each need to be P's, but it doesn't matter which one, right? All those P's look identical, so I'm just going to have 1 P there, 1 P there. Then I have 5 letters left to place. Now there's only 1 P left in that arrangement. So this is simply equal to 5 factorial, which is 120. If all of the P's are to be together, so this means all of the P's together. So I have all the P's together. These need to be grouped together. Then I still have the other letters, O, I, E, and S. So now I have 5 groups of things to arrange. I can go, this is equal to 5 factorial, which is 120. Now, if I was grouping different letters together that weren't identical, I would also need to multiply by 3 factorial, because I'm grouping 3 letters here. But since these 3 letters are identical, I don't need to do that. E, if the first letter is P and the next one is not P. So if the first letter is P, this has to be a P. Then the next letter is not P. Oops, I'm doing this upside down from how we did the first one. The second letter is not P. I have 4 letters that are not P, so I can put that there. Then I don't care about the rest. So then I have, am I missing any? Yeah, I'm missing a letter here. So then I have 5, 4, 3, 2, 1. But in here is still 2 P's, so I need to divide by the 2 P's. So if I want to do this in factorial notation, it would be 4 times 5 factorial divided by 2 factorial, which is 240. So you really can use the fundamental counting principle when you have repetitions, but you do still need to just remember to divide by the -2 there, or the number of repetitions. Example 2. A class consists of 5 girls and 7 boys. A committee is to be formed consisting of 2 girls and 3 boys. Determine the number of ways a teacher can choose the committee if there are no further restrictions. So we need to decide whether this is a permutation or a combination. So here we are just forming a committee of 2 girls and 3 boys. It doesn't say anything about giving each one a specific position or that choosing Amelia before Lacey is going to make a difference. So we know that this is a combination. So I need to choose 2 girls from 5. So 5 choose 2 times 3 boys out of 7. So this gives me 5 choose 2 times 7 choose 3, which is 350. B, Johnny, the principal's son, has to be on the committee. That doesn't quite sound right, but we'll go with it. So if Johnny, the principal's son, has to be on the committee, that means from the 5 girls, I am choosing 2. So we're still having a committee with 2 girls and 3 boys. So from the 5 girls, I'm choosing 2. But now I have 6 boys left to choose from to fill the remaining 2 positions because Johnny already took 1 position. So I have 150 committees that would be like that. If the twins, Peter and Paul, cannot both be on the committee. So I have 2 ways of doing that. I can consider Peter only, or Paul only, or neither. Or I can take all committees, that doesn't look right, all committees minus both. So all committees would be represented by 350, just like in part A, minus, well, how many have both? Well, the ones that have both, well, I still need to choose the girls, so I still have 5 choose 2. But now I'm saying I chose both Peter and Paul. So that means I have 5 males left to choose from, and I need to choose one of those.